Section 8.2 is solving problems that involve rates. There's lots of great examples in the textbook. I'm just going to go through one in the textbook. The other ones are there and are good to read over. So just exploring, a car travels 80 kilometers an hour. What other rates using different units could be used to describe the speed of the car? What would be some advantages? Okay, so we went from 80 kilometers an hour and we converted to kilometers per minute. So notice we set up a conversion factor. We said 1 hour is equal to 60 minutes. They put the hour on the top, so those hours would cancel out and we get kilometers per minute. And they got 1.33 kilometers per minute. For meters per second, we had to do a double conversion. First of all, and we could do this in either order, they got rid of kilometers. So kilometers on the top, they put kilometers on the bottom. They said 1 kilometer is equal to 1,000 meter. Remember, kilo means 1,000. So they canceled that out and they got meters on the top. Then they said 1 hour was on the bottom here, so 1 hour is equal to 3,600 seconds. They did their multiplying, they did their dividing, got 22.22 meters per second. Okay, for miles per hour. And this is something that is interesting when you talk to people. Sometimes older people talk this way, or people from America talk this way. They say miles per hour, and you're talking kilometers per hour, and you don't know who's going faster. Okay, so if we want to do miles per hour, I say kilometers is on the top, so I put kilometers on the bottom, and here's the conversion point, 621 miles. And the good thing about living today is almost every phone has a conversion, or every calculator does, or you can quickly look up in the internet if you don't know this off by heart. So for kilometers per hour, they went kilometers, 0.621 miles per kilometer, and they got that's 49.68 miles per hour. Maybe you want to do feet per minute, there's that calculation, or feet per second. So why would it be advantageous? They said, for example, in the United States, so you could communicate with someone in the States how fast you were going. And in other situations, it may be necessary or preferable to use other units to make comparisons. So if you want to know the distance from a point on a road to a crosswalk in meters, you may want to express the speed of a car in meters per second. So I wanted to know how far it was from one point to another in meters. If I knew how fast my car was going in meters per second, then I could just count the number of seconds it took me to get there, and I would know how many meters it is away. Okay, so Jeff lives in a town near the Canada-US border, so maybe he lives in Windsor. The gas tank of his truck holds 90 liters. He can either buy gas in his town at $1.06 per liter, you can tell how dated this question is already, or travel across the border and fill up at 286 US per gallon. So which option makes the most sense? So we have a couple conversions too. First of all, we're talking about Canadian money and American money, and then we're talking about liters and gallons. So let's see how Jeff does this. The cost to fill up in Canada is 90 liters times $1.06 Canadian per liter. It's going to cost him $95. Okay, now he's going to convert that 90 liters to US gallons, and 1 gallon equals 3.79. Notice liters, cancel out, he wants gallons. So he needs 23 gallons. Then what he has to do is he says, well, it's 286 US per gallon. So gallons cancel out, and it's going to cost him 67 US. And now at this point, the conversion, it's $1.02 Canadian for 1 US. He is going to cancel out US, get Canadian, it's going to cost him $69. Wow, way cheaper to buy gas in the US. The difference in cost is about $26.13. So in this day, it was more economical to fill up in the States. So for him to cross the border was more economical. Of course, this problem hasn't taken into effect all the taxes that we pay and the fact we get health care and all that stuff, but I won't go into politics right now. What other factors will affect Jeff's saving each time he considers to fill up? He would need to find the price of gas each time he considers. He should realize that the price could change at any time, so the cost per gallon when he arrived might be different when he checked it. Also, the cost in Canada could change. If the exchange rate was greater or less than that, his savings would increase. If it was greater, it would decrease. Jeff only considered the cost. What other factors where should he consider? There you go. There's the cost to drive to the station, okay? and the time it takes to cross the border. Depending on what's going on, you can sit at that border for a long time. Okay, so he thinks that a savings less than $10 is not worth his time. If he had half a tank of gas, would it be worthwhile? And that depends. If he had half a tank of gas in his truck, he would be buying half as much gas, so his saving would be half as much. So instead of $22 or $23, it'd be only $11. Without considering it would be worthwhile. The cost he would use driving would reduce the savings, so it might cost him more. Okay, so key ideas. When you're given a rate problem that involves an unknown, you can solve the problem using a variety of strategies. Often a problem that involves rates can be solved by writing an equation that involves a pair of equivalent ratios. To be equivalent ratios, the units in the numerator of the two ratios must be the same and the units in the denominator must be the same. So we have to convert. Paying attention to the units will help you write the equation correctly. A multiplication strategy can also be used to convert between units. Including the units with each term in the product and using unit elimination helps you verify that your product is correct. So don't be lazy, write all your units out. When a rate of change is constant, writing a linear function to represent the situation may be useful. So look in your book for some examples of that.